it's Mrs. Miner, and we are doing the Covalent Molecules of Fun Lab. So, if you are an in-person student, you hopefully got a copy of this, and if you didn't, sorry. Otherwise, you are welcome to type this, and then you can just insert your pictures of your drawings as best you can. So we are going to put all the answers into this lab report. Follow the directions in each section. All virtual learners and L through Z students, please watch the video of me making the models and then complete this report. Use subscripts correctly. So remember that we're talking about putting this little 2 down low. You guys are big kid chemistry students now, and so you need to be doing this correctly, all right? So background, a covalent bond is formed when atoms share electrons. Molecules made up of covalently bonded atoms may be polar or nonpolar. So remember, polar means charged and nonpolar means not charged. So polar molecules have groupings of electrons that are not balanced, and nonpolars have them evenly distributed. Many physical properties of matter are the result of the shape and polarity of molecules. In this experiment, you will construct models of molecules, or I will anyway, and determine their polarity, molecular and electron geometry, and bond angles. So I'm going to do one of them with you, and then I'm going to show you what those models will look like. So pause, or I should say listen to directions, and then pause your video real quick. So you're going to go and do your personal engagement. So you have 3 questions. This first one is to figure out the chemical formula for benzene. So if you just Google benzene formula, you'll find it. Super, super easy. There are 3 different ways to draw the structure of benzene. So research the Lewis structure of benzene and put a picture of that in the space below. So since you're researching this, you are allowed to copy and paste this off the internet. That's perfectly fine. The rest of your pictures, you may not, but here in your personal engagement, you can. Benzene can be drawn 2 other ways. Research ring structures of benzene and put a picture of one of those other structures in the space below. Then you're going to list 3 practical uses for benzene. In other words, if you don't know what it is, it's probably not practical. So make sure that you understand what these things are. Okay, so pause the video and do that, and then meet me back here. Did you do it? Did you pause your video? I don't know. I can't tell if you pause or not. Well, that's not true. I can if I go look in statistics, but I choose not to at this moment. So exploration, research question that you are being given to work with. How do I determine the shape and polarity of a molecule using molecular models? Equipment, you get a model set. And so that model set comes with a key. So you're going to see those models here in a little bit. So the model set comes with a key. So each of these little colors in here means something different. So carbon is black, hydrogen is white, oxygen is red, the halogens are green, so that's chlorine, bromine, iodine, and fluorine. Nitrogen is orange, sulfur is yellow. We're not using sulfur, but you get the point. Okay, so that's our key. And then your VSEPR notes and or VSEPR structure summary sheet if you decided to fill that out. So procedure, go to the analysis section and look at the table. Then watch the video of me making the models. Hey, guess what you're already doing? And fill the table in as you go. If you can print your table, you can fill it in manually. Take a picture and upload it with this document if you would rather fill it in electronically. So in other words, you still have to draw them. You may not take pictures off the internet and put them into your drawings. If you need to, draw them on notebook paper, and then you can insert that picture onto, just create a new page in Word and then insert that picture. So I'm going to make molecule models of the following molecules. So there's 10 of them. So benzene is the one that you did for your personal engagement. So I'm going to draw this. Its molecular geometry is cyclic because it's a ring shape, and so when you see it, you'll understand if you haven't already gone and looked at it. And then there's no bond angle that you need to know of. All right. So in a table, 1 at a time for each of the molecules listed in number 1 above. Pause the video as needed to complete each row 1 at a time. You're going to draw the Lewis structure, watch the model being built by your teacher. You won't see me build all of them, but you will see pictures of all of them. Predict the molecular geometry and draw the VSEPR shape. determine polarity and bond angle, and do not use the electronegativity sheet. So we talked about how there are two questions to figure out if something is polar or nonpolar. You look at the outside atoms and see if they all have the same number of electrons. You look at the central atom and see if it has unbalanced pairs of electrons. All right, so the data table is on the next page of this document. If you would like to print and take a picture of the table on the next page and upload it to Canvas instead of just retyping, drawing your molecules, you can't draw your molecules in Word, guys. Like, it's really hard to do. So just draw them on paper and put them in there. And be sure to write clearly, because as you're scanning this, I need to be able to read it. Okay, so be sure to put a title in the table. So up here, we need to put a title in our table. So I might say Molecules of Fun table. I might, because that's the name of the lab, is Molecules of Fun. I might say Vesper versus Polarity. Anything like that, but you need to put a title up in that table. All right, so we're gonna start off, these are our 10 molecules that we're going to draw or build. So we're gonna start off with the Lewis structure for HBr. Hydrogen gives me 1 electron, bromine gives me 7, so that's gonna be 8 electrons total. Divide that by 2 to make 4 pairs. So I'm gonna put the H and the Br next to each other, bond them together. Once hydrogen forms a bond, that's all it can do because it only has 1 valence electron. So the other 3 pairs will go around the bromine. So that's what my Lewis structure will look like. So in my notes, I would go through, and I didn't bring my Vesper summary sheet, so sorry. I would go through and I would look and I'd say, okay, there's 1 electron domain here. If there's 1 electron domain, then that electron geometry is linear. And since it's bonding, it will be the same. So this is a linear molecule. And so I would redraw this to be in a straight line, although it's already in a straight line. And I'm gonna look at my model. So let me go grab our little model here. So remember that there is a key. Hydrogen is white and the halogens are green. Notice, come back here. Notice we are in a straight line. Doesn't matter what we do, they always come back in a straight line. Here we go. Ta-da. So I need to make sure that my Vesper drawing looks like this model. The bond angle for a linear, remember I would put my protractor here in the middle and I'm gonna measure from the white to the green. That would be 180 degrees. And then is this polar or non-polar? So I'm gonna look at my outer atoms. Does one of these outside atoms have more electrons than the other? Yes, bromine does. As soon as you get a yes, this is a polar molecule and you just put the P there. Okay, so I'm gonna put that one off to the side. So I'm gonna ask you to go ahead and pause your video and draw your Lewis structure for water and work your way across here. Did you do it? I don't know, I may be talking to myself. So here is my water molecule. So you're gonna notice that your water molecule, I have my oxygen here. So in your drawing, you should have lone pairs on your oxygen. My little oxygen molecule here does not have spaces for me to put lone pairs in there, but it does show me that this is a bent molecule, right? It does show me that we're going down in those sides. So make sure that you put those lone pairs in for your Lewis or Vesper structure. Okay. Pause and do ammonia, which is NH3. Here we go. So this is what ammonia would look like. So I have my little triangle that's pointed down. So I like to, remember, put my hand on here. Anything that my hand touches is in the plane of the paper. So you have 1 hydrogen going towards you. That's your block arrow with the colored in triangle. And I have 1 going away from me, my stereo arrow, the two lines, okay? So pause and do nitrogen. Okay, so nitrogen should have a triple bond in there. And so when we do these triple bonds, we're gonna go ahead and put all 3 of them in here. Now this counts as a single electron domain, because even though there are 3 pairs of electrons in here, they are all in 1 space. Okay, so this is 1 domain. I went ahead and put the lone pairs in because I think the lone pairs help you to see that nice straight line that you have. Okay, so pause and do H2CO. Okay, so for H2CO, you should have a double bond between your carbon and your oxygen. So then remember that double bond counts as one electron domain, so I would have 1, 2, 3 electron domains. That oxygen definitely has more electrons than the hydrogen. So keep that in mind as you are picking the polarity. So we're gonna pause and you're gonna do CH3Cl, also known as chloromethane. You're gonna learn those rules later, well, I guess next week. Okay, so remember carbon is black, the hydrogens are white, so I went ahead and oriented this so that the chlorine was facing up. But I have the 3 of them down here. Now chlorine will definitely have more electrons than these hydrogens will, so keep that in mind as you do your polarity. No, and it broke. Why don't you pause this while I fix it? And you can do carbon dioxide. You ready? So here's carbon dioxide. There are 2 double bonds on either side and no lone pairs on this carbon. That's a really common mistake that people will make. Definitely in a straight line, and we've seen this guy before. So go ahead and pause and you can do methane. So here's methane. Very similar. Let me go get this chloromethane. They're very similar to each other, right? I mean, I obviously used longer springs on this one than I did on this one, but I mean, they're the same shape. They've both got that triangle at the bottom with the height going on here. The only difference is this one has a chlorine and this one is all hydrogens. Okay. Now, here are your 2 challenging ones. So this one we have CH3 and H2. So go ahead and pause and do that one. This one is my favorite. Do you know why? Because it looks like a puppy dog. Oh my gosh, do you see it? Can you see how it looks like a puppy dog? So there's the feet and the face, and here's the back feet, and there's that little lone pair on that nitrogen. It's a little tail. It's happy because this is called the covalent molecules of Fun Lab. So when you're doing the molecular geometry of this, anytime you have more than one center atom, carbon always wins. And we're gonna learn why carbon always wins when we start organic, but basically there's an entire branch of chemistry about carbon winning, okay? So when you go to draw this, how I tell kids to do it is I usually will put my hand over this and then I'll say, okay, draw your tetrahedral like you normally would. And then instead of trying to draw this back here, just write NH2. And then that way you can definitely see the tetrahedral that's here, okay? Enjoy that answer. Now, every puppy needs a water dish, right? So from the beginning, we had benzene. And here is your benzene. It won't even all fit on here. Isn't that great? So let me... Watch me break my iPad. Mrs. Miner, you're why we can't have nice things. Okay, here we go. Now you can see the whole thing. It's a pretty big molecule, isn't it? And it's definitely making a hexagon. We have alternating double and single bonds, which you should have seen when you research the Lewis structure in the personal engagement, which is why we have you, because some people will come up with this on their own. But if you're not naturally a three-dimensional thinker, this is a hard one to kind of figure out on your own. So remember that I said the shape of this is cyclic and no bond angle, so you're just going to put a big old Na there. But this is your benzene. So there's your water dish for puppy. And this is why I put the lone pairs of nitrogen. Puppy can have a snack. There's his bone. Ha, that's fantastic, Mrs. Miner. You have no idea how much fun I usually have with this. So come on. All right. So now that we've got our table all filled in, coming back here, you have questions to answer and you have an evaluation to do. So these are your directions. Once you fulfill this direction, delete it. I don't want the directions in the final lab. Okay, does that kind of make sense? So this tells you how to do this paragraph. This tells you how to do this paragraph. This tells you how to do this paragraph. I hope you guys had a little bit of fun, and Rover and I say bye-bye.